Now I'll show you how to build a 5-axis table machines. First, we need to open the step file that I prepared, the machine model. You must make sure the tabletop center, the rotary tabletop center, the reference point is at the model UCS, and also the spindle face at the model UCS, right? So move down the Z-axis if necessary. After you have this, then just export the component to STL file. So I'm going to export this one as a base, and I'm going to put tolerance 5 mm so that my STL file will be smaller, and this component also is not important, it's not used for collision checking. And let's export this one, the y-axis. This will be the y-axis, and again it's not important, let's put 5 and OK. And let's export again this one. This will be the x-axis in this case, x-axis, and let's put one more tight tolerance for this component, and OK, that's the x-axis. And then the next one will be the rotary body, and I'll put a tolerance of 1 and OK. And then again, how about the a-axis? This is the a-axis. Tolerance 1, and export pick. This is the a-axis. This is the a body. Put the body. So a is a body. It's 1 mm. It's okay. And then this will be table. In this case, this machine, this is actual machines. The table is not C, it's actually B. Just a name difference. So I'm going to name it as table. And let's put 1 mm. And again, the spindle. Spindle 1 mm. And the Z-axis, Z-axis, I'll put 1, and I think we have all the STL ready. Here's an example, like the machine body STL. I just copied this file from somewhere, just to show you. Sometimes if you have a complex machine body with many surfaces, and after you export, the file size is very big. This you can see here is 55.49. 55 meg. So this might slow down the machine simulations. To reduce it, you can always use mesh software. There's a free one in the market. For me, I'm using the software. Magic Excel. So you can see let's show you. You can see the triangle is a lot, okay, and that's why it makes the files big. For me, normally if I have no choice, then I always come here to do a triangle reductions and put the tolerance for 5 and OK. And afterwards, you can see the triangle is reduced. Just go do a fixing of just do all, and then again save the part back. Overwrite the I will not overwrite. Let me put a different name after edit. Okay. So that you can see the difference. Then I will save this file. It closes. You can see now, after I do some optimization, I am able to reduce this component size from 55 meg to 3 megs. Yep. Let's delete. Now let's go to the Cimatron 14 control panels. Go to the NC and open up a machine builder. And this is the software. And then what you need to just create a new, and then just save a new machine. So make sure you save. If you go to this folder, this location, make sure you create a new folder. I'm going to rename it 5xtt minus no space minus HAAS DF2 with TRT160. Copy this name. Okay. As this one. Okay. Then the XML file, you need to save the name of the XML file. You need to save exactly same as your folder names. Yeah, this has to be same, or else you have some problems. Then click save. Right. So after save, then inside this folder, you should have 5xtt. There you are. 5xtt HAAS here, one XML here, and also make sure you copy. Normally I like to use I like to copy everything here that we have prepared. Make a copy and put at these locations. Now let's start to adding the components. First, click here. This is a name. You can change any name you want. I will use the same name as a file. Unit machine organization zag up. Yes, for milling machine always zag up. If you have a turning machine, you use the X up. RTCP for this machine, no RTCP. Post versa, I will say later. Adapter type, yeah, we can choose it or set later, or leave it empty also okay. The feed and RPM, if you know, you just key. If you don't know, you leave it empty. To start, you need to add a base for the y-axis. So create an assembly. So base, and click OK. And on the base, I'm going to attach another assembly. We call it no. Let's add the base first. New mesh solid base. Right. So after I add a base, then I need to change the property here. The color I will put into dark color. You can put any color you want. Collision check, no, not necessarily for this. The visibility group I will put into the enclosure. Right. Make it safe. Next, I'm going to attach the y-axis. So create a new assembly. So y-axis, it is a linear axis. So y-axis on the base, and then I will attach the mesh solid, the y-axis solid, to the base. And again, I'll change the color to dark color, and no need to check for collision for this component. And also this is belong to enclosure. Yeah. Okay, so after set, adding the solid for the y, then we need to click the y-axis here to set the property. So for this, we need to set some property. The first one that you should set is this one, right? Is this one. So this is the axis vector. So for this y, for the machine, for the tool to go plus direction, this component will move at minus direction, right? Y minus direction. So we need to set this one to be y minus 1. Okay, this is vector for this component. And we need to also set the limits. So we need to check. So this is the limit, the y limit from the center. So I'll set the minimum will be minus 178, and the maximum is 228. The home position will be at the 228. Right, so you can always click on the axis here to just select the y, and then you can move it. So this is a plus directions, right? This side, and the other side is the minus directions, right? So you have to think of in case two move. If the two move y plus, then this component should move at y minus direction, right? Yeah, that's y. Next will be the x component, the x-axis. So is sitting on the y, so select the y and click new assembly and put x-axis. There's a linear axis, and I will load the solid for this x-axis. There will be a table, this table. So I'll set it in white color, and no need to collision check for this component, and belong the table group. Right. Then we need to set the property of the x-axis. So again, let's imagine for the 2 to move x plus direction, the table need to move x minus, right? Okay, in order for the 2 to move x plus, the table need to move x minus. This means that the axis is x minus 1. And again, the minimum maximum will be, minimum is minus 381, maximum is 381, right? And the home position for this machine is minus 381, means at this corner here, the x. So after it's set, you can always check whether your setting is correct or not. So this is the plus directions. When the 2 move x plus, the table will move x minus. So the movement is correct, and also the y, right, and the x. You must make sure that that direction is correct. Now let's add the a-axis. First, let's add the a body. Yes. No, the rotary body. Sorry, on this table. And I will change the property, the color, for example, to here, the black. And collision, no. Yes, I want to have collision check on this. And the table, yeah, it's belong to the table group. Yeah. Sometimes you can see the location is funny. Don't worry. What you need to do, just save and click new to clear everything, and open back the XML file. Now the location is correct. And next we're going to add a-axis components. So right click here, new assembly. So this will be the A. So rotary axis normally is ABC. So rotary axis. So what is ABC? I will show you this one. So if the rotary axis rotary center axis is parallel to X, then it will be the A-axis, right? And then B is Y and C is Z. Okay. If the vector is X plus direction, then the A plus angle is anti-clockwise. And same also the B and the C. So in this case, we have tested the machines. We move the machine this direction, and the angle is A positive. So it will be the X plus axis for the vector X plus. And we also check the distance from the tilt axis center here to the table is 50.8. This value is important. And also there's no off center, Y we need to check also if there's a off center, y plus or minus. In this case 0 0, right? So this is a axis, and let's add the solid for the a axis, and also we have a body here. This is a body. Don't worry if you see this problem like this, right? So let's change here. This color is okay. Collision, yes, is belong to table. The body, let's change color, maybe the green. No, the green, and belong to the table, right? That's for the solid. Next, let's look at the axis. So axis of rotations, we already checked just now from the drawing. So it is a x plus, so 0. And center rotations, so it is minus 50.8 from the table, from the rotary table. And limiter range and the limit, normally for this kind of rotary, the limit will be, maximum will be minus 120. You need to check on the machines, right? So, and the plus is 120. So this machine is this value, and the home position is 0. It's okay, right? So after you set, then you can always go to the, click on the A and test. So this is a plus direction, and this direction is a minus direction. Make sure the rotary direction is correct. Okay, so next we'll add a C-axis assembly. C-axis on the A, this rotary. But this machine, they don't call it C, they call it B. This is not standard, so I put B, but it's supposed to C, supposed to be C. And okay. And the B in this case, the rotary is a axis. Rotary axis is minus. It's a C minus Z minus 1. These directions. Okay, and center 0. And the rotary type is continuous, simple, not limited range. This one, continuous, simple. In other words, the rotary is shortest path, shorter path. So I will change this and add the table here, right? Then you can test it out. B. So this is a positive side. Another, this is negative side. Negative, it will be anti-clockwise. Positive will be clockwise. Now, how to test whether this rotary axis is limited range or a continuous simple or or what we call it shorter path axis. Okay, it's easy. Under MDI mode, you need to run this line of code, make the rotary to go to C0. After that, run this C350 and notice the movement. If the movement is 350, then this axis is limited range. If the C axis only moves 10, then this axis will be a shorter path axis or a continuous simple axis. Now let's add the Z axis. So the Z axis is sitting on the base, so we need to click on the base, click new assembly, and I tell you what, I'll do like this. I'll create one assembly called head, put on the base, and I will put head is on the base, so I will put the Z axis here, so Z, so it's much easier to manage like that. Z axis is a linear axis, yes, and okay, then I will put the solid Z axis here, and just change the color to maybe blue, and collision check, yes, and it's belong to head, yeah. And also I need to put the spindle as well, spindle. This is a spindle. The color of the spindle, let's put maybe this color. Okay, and collision check, yes, and it's belong to the head. Right, this is a Z axis. And how about the vector for the Z axis? Yes, the vector is what? For the Z axis, the vector is not this one. It's actually x0, y0, z1. Right. That will be the Z axis. And how about the minimum and maximum? So let's look at the drawing here. From the rotary table to the table, the height is 50.8 plus 196.9. It will be 247.7. And the machine limit from the table is 610. So the maximum is 610 minus 247.7. This will be the maximum, and the minimum, this will be the minimum. So the maximum is 362.3, and the minimum is minus 145.7. Right, and the home position will be 362.3. So you can test for it. And this is home position, the maximum height the machine that can go, and the minimum that the machine can go. Okay. Yep, that's it. We have done building a 5-axis table machines, and this machine is HAAS DF2 plus a 2-axis rotary table TRT160. save. Okay, I just forgot. We still need to add a tool on the Z axis. So just click here on the Z and click New Assembly Tool. Yeah. So this will complete the whole machines.